Picture a crisp morning off the coast of California. A small charter boat bobs gently in the swells as a local fisherman hauls up his net. He expects sardines or the occasional crab, but instead he finds himself face to face with a glistening ribbon nearly as long as his boat. The creature's silver skin reflects the sunlight like polished chrome, its crest of crimson fins waving as if it were a mythical dragon. The startled fisherman recognizes the animal from a newspaper article about a Japanese legend. Sightings of Oarfish, the king of herrings, are said to foretell earthquakes and tsunamis. He takes a quick photo, then releases the fish back into the waves. Was this just a freak encounter, a harbinger of impending doom, or evidence of something far more profound lurking beneath the waves? Keep watching, because by the end of this story, we'll discover why deep-sea creatures are suddenly swimming into our world, and what it means for all of us. For millennia, the ocean's depths have been a realm of mystery and myth. The waters covering more than 70% of our planet are home to more life than anywhere else on Earth, yet most of that life remains hidden. Explorers with high-resolution sonar have mapped barely a quarter of the seafloor, and scientists have seen less than 1,000th of the deep ocean floor with their own eyes. Estimates suggest there may be up to 1 million species in the ocean, 2/3 of which are still undiscovered. Today, however, a steady trickle of creatures from those unknown depths is breaking the surface and capturing headlines. Giant phantom jellyfish, with translucent umbrellas the size of houses, have floated near Antarctic research vessels. Smooth lumpfish resembling pink brains have tumbled into Russian nets. And black sea devil anglerfish animals that normally lurk hundreds of meters down have been filmed swimming in daylight off the coast of Spain. Even the fabled oarfish has become a common sight, with multiple live specimens reported in Mexico and California. So why are animals adapted for crushing pressures and perpetual darkness appearing in shallow, sunlit water? Is this invasion a sign of a coming cataclysm, a natural pattern we simply hadn't noticed, or a warning about how we're changing the planet? To answer those questions, we need to journey through a world few have seen. We'll explore the layers of the ocean, meet the bizarre denizens of each zone, uncover the invisible highways that guide their nightly migrations, and confront the environmental forces that are pushing deep-sea life toward the surface. Along the way, one ancient omen, the oarfish, will weave through our narrative, surfacing again and again as a thread that links myth, biology, and modern science. If you've ever stood on a beach and gazed at the horizon, you've only witnessed the ocean's skin. Beneath that sparkling surface lie layers as distinct as the floors of a skyscraper. The uppermost floor, called the sunlit zone, extends roughly 650 feet 200 meters down, where enough sunlight penetrates for photosynthesis to occur. Here, algae and tiny plant-like plankton churn out oxygen, forming the base of the marine food web. Dolphins, sea turtles, sharks and whales dominate this bright world, and coral reefs burst with color. Yet, even this vibrant layer is not fully known. Mapping efforts have revealed that more than 90% of the ocean is deeper than the sunlit zone. As light dwindles with depth, colors disappear in order of their wavelength. Reds vanish first, then oranges and yellows, leaving only ghostly blues and violets. The twilight zone begins around 650 feet and extends down to about 3,300 feet, 1,000 meters. It is a world of perpetual dusk, where pressure increases, temperatures plunge, and creatures adapt in astonishing ways. The strawberry squid, for instance, looks like a floating berry, with one huge eye that peers upward to detect silhouettes against the faint light, and a smaller eye pointing downward to spot bioluminescent flashes. Comb jellies called bloody belly ctenophores shimmer with rows of rainbow-like lights. Yet, in their natural habitat, they appear nearly black, because red wavelengths don't penetrate this deep. Many Twilight Zone species are draped in ruby hues for camouflage. Even deeper lies the Midnight Zone. Beyond about 3,300 feet, no sunlight at all reaches the water column. This pitch-black expanse is home to animals that seem ripped from science fiction. Barrel-eye fish have transparent heads, with upward-pointing, green, barrel-shaped eyes encased in a fluid-filled dome. Giant squids roam this realm with eyes as large as basketballs. their long tentacles stretching like elevator cables into the dark. Anglerfish dangle bioluminescent lures from modified dorsal spines to entice prey, while males tiny compared to females fuse their bodies to mates, merging bloodstreams in a strange reproductive strategy. Vampire squid drift leisurely with webbed arms resembling capes, living fossils from a lineage hundreds of millions of years old. At these depths, the sense of time blurs. Many animals are slow-moving, conserving every bit of energy in a world where food is scarce. Beneath the midnight zone, between roughly 13,000 and 20,000 feet, 4,000 to 6,000 meters, lies the abyssal zone, an expansive plain dotted with occasional seamounts and trenches. The temperature hovers just above freezing, and the weight of water above exerts crushing pressures. Yet, even here, life persists. Yeti crabs farm bacteria on hair-like filaments covering their claws, waving their arms in the chemical plumes around hydrothermal vents to feed their microbial crops. Dumbo octopuses cruise gracefully with ear-like fins that resemble the Disney character. Researchers have called them deep-sea ballerinas for their gentle pirouettes. The abyss still holds secrets. Explorers have visually observed less than 0.001% of the deep ocean floor, meaning entire communities live beyond our current knowledge. Below 20,000 feet stretches the Hadal Zone, a series of trenches and pits that plummet more than 6 miles deep. Only 3 humans have ever reached the deepest known point, Challenger Deep in the Mariana Trench, and only for a few hours. Pressure here exceeds 8 tons per square inch, and temperatures hover just above freezing. Despite these harsh conditions, amphipods, snailfish, and microbial mats thrive. Because our story focuses on creatures that ascend toward the surface, we'll leave the Hadal mysteries for another day. For now, remember that the deep ocean is layered, vast, and barely explored, and that the animals we're about to discuss are uniquely adapted to their dark homes. When sunlight fades, many deep-sea animals make their own. Bioluminescence is the ability of living organisms to produce light through chemical reactions. In most cases, a molecule called luciferin reacts with oxygen, in the presence of an enzyme called luciferase. The reaction releases energy as light instead of heat. Some animals house these chemicals within specialized organs. Others rely on symbiotic bacteria to generate glow. In the twilight and midnight zones, bioluminescence serves multiple functions. Predators lure unsuspecting prey with glowing lures, like the anglerfish's fishing rod. Prey species emit flashes to startle predators, or to confuse them while escaping. And some animals use patterns of light pulses to communicate and find mates. Imagine drifting through total darkness and witnessing a burst of twinkling signals swirling around you. It's as if the cosmos has sunk beneath the waves. By now, you might be thinking, these creatures are perfectly suited to the deep. What could possibly entice them upward? To answer that, we need to uncover a hidden movement that occurs every single night, involving billions of animals rising toward the surface. But first, let's recall the omen from our hook, those ribbon-like oarfish that fishermen sometimes haul up. They live deep down, but occasionally they venture higher. Could their appearances be linked to the same ancient rhythm? The answer lies in the largest migration on Earth, and the US Navy stumbled upon it by accident. During World War II, sonar operators scanning the Pacific noticed what looked like a second seafloor, hovering a few hundred meters above the real one. At night, this false bottom rose toward the surface, and at dawn, it sank again. Navy officers initially suspected schools of submarines, but scientists later discovered the phenomenon was caused by layers of fish, squid, and plankton that moved en masse. Today, we call this phenomenon the deep scattering layer, and it forms the backbone of the diel vertical migration, DVM. Every evening, billions of organisms, ranging from microscopic zooplankton to fish the size of a loaf of bread, swim hundreds or even thousands of feet upward. They feed near the surface, under cover of darkness, and then retreat to the depths before sunrise. This daily commute happens in every ocean basin, making it the largest migration on Earth by sheer biomass. Imagine a river of life 25 times heavier than all of humanity, silently surging up and down every day. Why do they expend so much energy on this nightly commute? The answer is a trade-off: food versus safety. Photosynthesis only occurs in the sunlit layer. so phytoplankton and tiny algae flourish near the surface. These plants provide food for zooplankton and small fishes. Yet daytime foraging leaves these small organisms exposed to predators that hunt by sight. By waiting until after sunset, the migrants can gorge on plankton under the cover of darkness, then slip back into the shadows before dawn. Light and temperature also influence their movement. Some species respond to faint moonlight by diving deeper, while others are triggered by daily temperature cycles or chemical cues. This cycle is embedded in their physiology like a circadian rhythm. The vertical commute doesn't just shuffle animals, it also transports carbon. When billions of organisms ascend and feed, they ingest carbon-rich phytoplankton. Upon descending, they excrete waste and dead particles that sink, effectively ferrying carbon from the surface to the deep ocean. This process helps regulate the global climate by sequestering carbon dioxide in the ocean's depths. Disrupting this migration could therefore disrupt the planet's carbon cycle. But what happens when this nightly dance begins to change? In the past decade, scientists have noticed unusual patterns. The deep scattering layer is shifting. Some species remain near the surface longer. Others are moving permanently toward cooler waters. To understand why, we need to consider the profound changes happening in the ocean itself. Before moving on, think back to our oarfish legend. Oarfish typically inhabit depths around 1,000 meters, 3,300 feet. When injured, or at the end of their life, they occasionally drift near the surface, which might have given rise to the myth that their appearances foretell disasters. But could there be another reason we're seeing more of them alive? As we'll soon learn, the environment these animals call home is undergoing rapid change. One of the most underappreciated facts about climate change is that the ocean absorbs the vast majority of the excess heat trapped by greenhouse gases. According to NOAA, the ocean stores about 90% of the extra heat energy accumulating in Earth's climate system. When our atmosphere heats up, the upper layers of the ocean warm as well, causing water to expand and sea levels to rise. Yet deeper water remains cold because sunlight doesn't penetrate far. Warm water is less dense than cold, so it stays near the surface. Without mixing, the oxygen from surface waters cannot reach the depths. Warm surface layers also hold less dissolved oxygen than cold water. Since oxygen solubility decreases with temperature, the result is a stratified ocean with expanding oxygen minimum zones, regions where oxygen levels are dangerously low. For deep-sea species adapted to stable, oxygen-rich conditions, warming and deoxygenation can be deadly. Some animals respond by shifting their daily migrations. They ascend to the surface earlier or remain higher in the water column longer to access oxygen and food, even if it increases their risk of predation. Others embark on permanent relocations. Studies project that as oceans continue warming, deep-sea species could migrate 4 to 11 times faster than species living near the surface. Many will head toward the poles to escape the heat, altering entire ecosystems. Researchers from the University of Western Australia documented a humpback anglerfish, a species normally residing at depths of 200 to 600 meters, swimming near the surface in Tenerife, Spain, and hypothesized that rising water temperatures or the fish's final life stage might have driven it upward. Similarly, more oarfish are being spotted alive because warming waters and oxygen shortages may push them higher in the water column rather than only surfacing when injured. Changes in ocean chemistry further exacerbate stress on deep-sea life. Human activities introduce pollutants like heavy metals and microplastics that sink and accumulate in the deep, potentially poisoning long-lived species. But perhaps the most immediate human threat is deep-sea mining. The extraction of metals like cobalt, nickel, and rare earths from the abyssal plain, and hydrothermal vents. These operations could devastate habitats that took millions of years to form. Because deep-sea ecosystems recover very slowly, disturbance from mining may mean permanent loss of species. Before we even discover them, all these stresses create a perfect storm. When oxygen becomes scarce, heat increases, and habitat disturbance escalates. Creatures will do whatever they can to survive. For some, that means shortening or skipping their nightly migration. For others, it means ascending to shallower waters or heading toward cooler latitudes. Each time an anglerfish swims higher, or a giant phantom jellyfish glides near the surface, they become ambassadors from a hidden world, warnings that their realm is being altered by forces they cannot control. Our once mythical omen, the oarfish, reappears in this context, not as a harbinger of earthquakes, but as a signal of environmental stress. Its sightings tell us that deep-sea habitats are changing, and that the creatures who live there are looking for refuge. At this point, you might be wondering, is there any hope? The revelation that 90% of climate-driven heat resides in the ocean, that oxygen minimum zones are expanding, and that deep-sea animals are being forced toward the surface may feel overwhelming. But the story doesn't end with doom. The very fact that we're noticing these patterns signals that science is catching up to the deep. Advanced submersibles, remote-operated vehicles, and new satellite-linked buoys are allowing oceanographers to monitor temperature, oxygen, and carbon cycles at unprecedented resolution. Research into diel vertical migration shows how intimately the ocean's biological pump is tied to climate regulation. Understanding these processes can help policymakers design better conservation strategies. However, awareness alone won't stop the changes. While the ocean shields us by absorbing heat and carbon, that service has limits. Continued greenhouse gas emissions will intensify warming and expand oxygen minimum zones. Nations face a choice: accelerate the shift toward renewable energy and sustainable practices, or risk transforming the deep sea into an inhospitable desert. Ultimately, preserving the deep is not just about saving bizarre creatures. It's about safeguarding the ocean's capacity to regulate Earth's climate and support life as we know it. The stakes are higher than a single species surfacing. They encompass the stability of our planet. So, why are deep-sea creatures coming to the surface? The answer lies in a convergence of natural cycles and human-induced changes. On one hand, diel vertical migration has always drawn countless animals toward the surface, under the cover of night, a hidden pulse of the ocean that sustains food webs and sequesters carbon. Oarfish, squid, comb jellies, and anglerfish may briefly appear when they follow prey, or when they're injured or spawning. These fleeting glimpses, once so rare that they inspired myths, are part of the ocean's normal rhythm. On the other hand, climate change is altering that rhythm. The ocean absorbs about 90% of the heat trapped by greenhouse gases, warming the upper layers and reducing oxygen. Warm water holds less oxygen than cold water, and stratification means oxygenated surface water doesn't mix down. Deep-sea animals adapted to cold, oxygen-rich environments find themselves suffocating. Many respond by ascending permanently or migrating toward polar regions. Meanwhile, rare events like a humpback anglerfish swimming near the surface of the Canary Islands suggest that localized temperature anomalies or life cycle stages can push individuals up. Humans are also adding stress through pollution, acidification, and the looming prospect of deep-sea mining. Thus, when you read about an anglerfish washing ashore in California, or watch a viral clip of an oarfish undulating near a pier, you're witnessing more than a random oddity. You're seeing the intersection of ancient behavior and modern disruption. The deep is sending emissaries, and they are telling a story about our planet's health. It's easy to feel detached from the darkness beneath the waves, but the deep sea is intricately connected to our everyday lives. It moderates Earth's climate by storing heat and carbon, supports fisheries that feed millions, and houses organisms that may hold cures for diseases we haven't yet discovered. Yet we have explored less than a tiny fraction of this realm. The sudden appearances of deep-sea creatures should not inspire fear, but curiosity. They remind us that the ocean is dynamic and vulnerable, and that we are stewards of its future. If this journey into the abyss left you with a new sense of wonder, consider supporting ocean science and conservation. In the United States, you can follow NOAA's Ocean Exploration Program, donate to non-profits fighting for marine protected areas, or simply reduce your carbon footprint to slow the warming that threatens our seas. Share this video with friends to spark conversations about the deep, and don't forget to subscribe to the channel for more stories that illuminate hidden worlds. The next time you hear about a strange creature surfacing, you'll know that behind the headline lies a complex, interconnected story, one that involves ancient migrations, modern climate change, and our collective choices. Together, we can keep the ocean's mysteries alive for generations to come. Beyond personal lifestyle changes, we can engage with broader efforts to safeguard the deep. The United Nations is currently negotiating a treaty that would establish marine protected areas on the high seas, zones beyond any single nation's jurisdiction. Coastal communities can organize beach cleanups, monitor water quality, and participate in citizen science projects that track changes in local marine life. Educators can weave ocean literacy into school curricula so that curiosity about the sea starts early. Even sharing documentaries like this one can inspire conversations and build a culture that values ocean stewardship. The ocean has given humanity myths, food, and climate stability. Returning the favor isn't just charitable, it's essential.